Hi, I'm just going to do a discussion on CVE 2017-0144, which was Windows SMB remote code execution vulnerability. This was better known as Eternal Blue. This CVE was the one associated with it, but the Microsoft Security Bulletin for MS-17 also included Eternal Synergy, Eternal Champion, and Eternal Romance. So essentially what this lets you do is it lets you send a specially crafted packet to an SMB v1 server, and it allows arbitrary code execution. So I'm going to go through how to manually do this exploit using Warwick's GitHub, and then we're going to do a little bit of discussion on it. So first you can see I was already working on this, so I'm going to delete the payload that I already have. Just start from the beginning. And the first thing we need to do is, so you need the MySMB library there. The shell code for this, mine's at x64. If you have if you have a 32-bit operating system, there's one for 32-bit, and I'm going to be using the Windows 7 exploit for this. And so the first thing I need to do is compile the shell code here, and I already have the command ready to copy and paste, so I don't have to type it all out. Oh, looks like I deleted it. There we go. Okay, so make sure that's output, and now I'm going to need my payload to throw in there so I can get a reverse shell. And you see, so I'm going to output that as a binary. I want to connect back to my local machine on port 444, and it's a reverse TCP shell. So we run this. Once it finishes here in a minute, okay. We are going to concatenate this payload onto the end of the shellcode. So if we do this, what's the name? What did I name it? Payload. There we go. Let's call it something like full exploit .bin. Okay. So now that we have that, we can now. It is important to note that this exploit only is working on Python 2. It has not been updated for Python 3 for whatever reason. I'm assuming because it's an older exploit. There's been no reason, like this is 6 years old. It hasn't been modified since. So this is the IP to the Windows machine I'm using to test on. And we have the shell code here. What I even name it? Full exploit. Okay, and we want to make sure that Windows machine is up because the Eternal Blue exploit is very unstable and sometimes crashes the machine. Okay, so I get my listener up over here, and we run this, and we look over at the listener, and we see that it did not work. And so the reason for that could be multiple things, but we're gonna do a little check on it here. So it looks like it actually fixed itself. I just ran it again and it decided it wanted to work this time. So, okay. Like I said, this is a very unstable exploit. It appears that the Windows machine, yes, it has encountered a critical problem and will restart automatically. I believe when I was looking it up, this was due to what it decides to overwrite in memory. Sometimes it will crash, sometimes it won't crash. If you look in his actual directory, I think he said it crashes. Yeah, this might fail or crash on entire system depending on what is overwritten. So it crashes a lot. But now I'll just do a little discussion on what this vulnerability is and how it works. So basically, SMB is a service in Windows which allows you to read and write files and request services from the server programs in the computer network. Like I said earlier, this exploit allows for arbitrary code execution through crafted packets in an SMB server. And I don't think desktop audio is on, but the Windows machine just restarted. So this actually occurs because of a combination of 3 different bugs. So the first bug in this chain is a integer overflow caused by wrong casting, and so basically there's the there's an OS2 structure for a fee list, which is a file extended attributes, which is used in the SMB. Um, and basically, it converts when the SMB is taken in, it converts it from an OS2 fee list to a NT fee list, and it if it's the wrong size here, I'll actually just pull this over. Um, so you see that this is a U long right here. Well, if it's a wrong size, it attempts to put this into a U short, um, which makes the OS think that the size of the buffer is actually larger than what it is. And like I said, like it says right here, this causes the problem. The CV list size is greater than the NTV list size, which causes an out of bound write. Um, and the guy in the video, I have to find it again and link it. He did an analysis at DEFCON of this entire exploit, and he was just wondering why they didn't just reject the packet instead of trying to correct it. But Windows. The second bug in this is the wrong parsing of an oversized trans2 request. So basically, when files are sent through SMB, it utilizes com transaction2 and nt transact subcommands. The transaction2 command allows for clients to set and retrieve extended attribute key value pairs, which make use of long file names that perform directory searches. The transact commands allow for transfer of very large parameter and data blocks. When data sent over either of these exceeds this is max buffer size, it will utilize the secondary subcommand. And this is only supposed to be used when too much data is sent in the packet. So basically, the secondary for the transaction 2 can store a max data length of word. Okay, and the transact command can store a D word. Like it says, basically no data validation is occurring here. Like no validation is occurring here to see what started the transaction. It only looks at what the last transaction type was. So it is possible to send an int transact followed by a transaction secondary. Okay, and as I said earlier, the transaction secondary is a D word. Okay, so basically, okay, so I clarified some things. So basically, when you send the nt transact followed by the transaction secondary, it basically makes it think that it only has something of size word, even though the nt transact is of size D word. Okay, so this causes the first packet to actually occupy more space than what is allocated, since only a word is allocated, even though transact occupies D word. So that's the end of the second bug. So basically all this stuff is set up for the third one. So the third one is the session setup memory allocation error, and so when the memory is allocated on session setup, basically you can confuse the server into reading the wrong offset for the data block. This allows for the reservation of a large amount of memory, and when closing the connection, this is something that SMB just does. It immediately frees all that memory, and from what the guy in DEF CON was saying, this is still currently in Windows. Apparently this is not a vulnerability on itself, and it's only a big vulnerability because it's chained with all this other stuff. This is used in heap grooming, where a hole is created that is filled with a data size that causes an out-of-bound write to the next chunk. This eventually allows for the insertion of a payload, which is called during the cleanup function when the session's closed. However, because of the where this is located in the actual calls, you can't use the same libraries that you would normally be able to use. So this is actually much more complicated, and I'm not going to go too into that. I will have the video for the talk linked down in the description, because he does a very, very good job at explaining this. and there's also an article. Let me see if I can find it, but I'll link that down in the description too. So that's all for Eternal Blue.